Hi, Assalamualaikum again. Okay, so we continue with the critical ratio or CR. Critical ratio is organized based on the due date and it mostly done in the service. Okay, and the formula for critical ratio is the time remaining divided by the work days remaining. And to get time remaining is from the due date and the today's date. So these are the example in which the current day is at day 25, okay, and we have 3 jobs and these are the due date on the day 30th and 28th and 27th. So these are the work days remaining and these are the calculation in which we have the formula of due date minus the current 25 and divide by work days remaining in which we have 1.25. So we do for B and C and how to set the priority. So any value CR less than 1, the job is already late. Okay, and job C is on the schedules but is 1 and then A have some slack time. Okay, the critical ratio technique is relative based on the priority and it's more on the track of the job progress. Okay, this is a very important one, the Johnson rule. Johnson rule is the scheduling for more than 2 machine or workstation. Okay, these are the steps. So let's see the example. Okay, and the limitation of the Johnson rule, it doesn't include the due dates and doesn't look at the upstream or downstream for the overall process. Here we have 2 machines. Machine 1 is the drill press, machine 2 is the lathe machine, and we have 5 jobs A, B, C, D, E. It says that job A need to go to machine 1 and then followed by machine 2. Okay, so we need to follow the sequence. Now we're going to do the Johnson rule sequence. So since we have 5 jobs, so we have 5 section here. So we need to know what is the best sequence. Okay, so how to do Johnson rule? We look at the both column and find the smallest or the minimum processing time. Okay, this one in hours. So we found out that 2. Okay, so number 2, we need to identify whether it's in the first machine or second machine. So since it's in second machine, so we will go from the back. Okay, so A will go here. So we're done. So next smallest is number 3. Okay, number 3. Since number 3 at the first column or first machine, it will go from this side. Okay, so B gonna be here. And then we're done with B. Next is number 4. Okay, 4 is the smallest. And we know that 4 at the machine 2 or column 2. So it will go from this side. And it must go to next to A. So C going to be here. And then, okay, now we have tie, number 7. Okay. And then we will look at the which column or which machine. So we do the first one at the first column or machine is E. So E gonna go through here. So after B is gonna be E. Okay, and automatically we know that D will go in the middle. So we have the Johnson sequence of B, E, D, C, A. So where to use B, D, C, A? We will use in this table. We call this in and out table. First is the machine 1 and these are the machine 2. And the job that we have done, B, E, D, C, A, we will put it here. Okay, and then what we're gonna put inside this table, remember these are the information given. So we start with 0 and we will read machine 1 first because we're doing the machine 1. So B machine 1 is 3, so 0 plus 3 is 3. We bring 3 here. And then E at machine 1 is 7. 3 plus 7, we get 10. And then bring 10 here. And then D machine 1 is 10. 10 plus 10 is 20. Bring down 20. And C machine 1 is 8. 20 plus 8 is 28. And bring down here 28. And we know that A is 5. So 28 plus 5 is 33. So we complete the machine 1. Now we're going to do machine 2. So we start with, take the number from this column. So 3 plus, now we look at the machine 2. Okay, be careful. Machine 2, B machine 2 is 6. 3 plus 6 is 9. Okay, before we want to bring what number here, we need to compare between this number and this number. Which one is the biggest one? So 9 and 10. So we're going to choose 10. So 10 will add. So E machine 2 is 12. Is 22. Okay, again, what number to bring here? We need to check which one is the biggest. 22 and 20. So we're going to choose. So going to be 22 plus. We look at D machine 2 is 7. 22 plus 7 is 29. Again, we need to check first. 28 and 29, which one is biggest? 29. So we will bring 29 here. And we look at C machine 2 is 4. 29 plus 4 is 33. And we check again, 33 is the same. So we will use 33. 33 plus A machine 2 is 2. So we have 35. Okay, 35 is very important because 35 is the total processing time or total throughput time or total overall machining time. So this one is very important. So it will give us 35 hours. Okay, because it's in hours. So you need to write the unit here, minutes, hours, seconds. So you need to check what is the unit for this question. Okay, now we're going to look at the machine idle time. So we have two machines here. So we look at machine 1. Idle time means that the machine don't do anything. The machine is waiting. Okay, menunggu, tak buat apa. So we look at the first machine. So we know that there's no idle time for machine 1. From starting, they do job and then next job E, next D, C, and then A. And then it's complete at time 33 hours. But total overall is 35. So what is the idle time for machine A? So machine A have 2 hours, okay? Because it finished at 33, but the total processing time at 35. So machine 1 have idle time for 2 hours, okay? Because it's completed at 35 for machine 2. So idle time for machine 1 is 35 minus 33, you get 2 hours. Okay, now let's look at machine number 2. So the first idle time is at the beginning, in which job B is inside machine 1 and machine 2 is waiting for job B to finish in machine 1. So machine 2 only start at hour 3. So it have 3 hours waiting time. Okay, before job B can go into machine 2. Okay, next we need to check between time out and time in here. So here we know that they finish at 9, but job E only start at 10. Okay, time 10. So we know that there's 1 hour waiting time. Okay, for this one, 22 and 22, nothing, no idle time. 29, 29, no idle time. 33 and 33, no idle time. So the only in between is at this one. So it's 1. So now the idle time for machine 1 is 3 plus 1, we have 4. Okay, now let's look at the job waiting time. Job waiting time is want to know whether job B, job E, job D, job C, or job A have queuing time or they are waiting to go into machine. So how to check? We check at this time out for machine 1 and time in for machine 2. If there any different, the first one, no. The second one, no. Yes, there's a difference in time here. So 22 minus 20, we get 2 hours waiting time for job D. So job D is waiting outside machine 2 before job D can go at time 22. And then for this one also, there's a waiting time for job C. They have to wait for 1 hour. And this for A is okay. Okay. So we need to total up. So the job waiting time is 2 hours plus 1 hour. So the total is 3 hours. Okay, now we're going to summarize. So we have calculate that the machine 1 have idle time 2 hours, machine 2 have idle time 4 hours, so the total machine idle time is 6 hours. And then for job waiting, we know that it's 3 hours and the 5 job are completed in 35 hours, okay, in which we get from the last number at the in and out table because it shows us the completion time. Okay, once we have finished, we need to do the Gantt chart. Okay, the Gantt chart we need to do for machine 1 first. Okay, and then we start with 0 and 3 is B, and then 3 and to 10 is E, 10 to 20 is D, 20 to 28 is C, and then 28 to 33 is A. So bear in mind we need to do until the end 35 here. Okay, so you need to put this one is the idle time. Next we're going to start with the machine 2. Okay, machine 2 first we have 0 to 3 we have no activity, so 0 to 3 gonna be idle, and then we only start at 3 to 9, so 3 to 9 is B, and then 10 to 22, so we have 9 to 10 we have 1 hour here, remember, so we only start at 10 to 22 for E, and then 22 to 29, and then 29 to 33, and then we have 33 to 35. So we have complete the Gantt chart. Okay. So this one we need to put in different shade or color. So this one to show that these are the idle time. Okay. Actually, if in the real situation, you don't have 2 machines, you have more, maybe 6, 7, 8, 10, 20. Okay, so if you have lots of machines, you cannot do it manually, just like the one I show you. So you can use software. MRP, you have software for MRP, you have software for aggregate planning, you have software for all the sequencing and scheduling. Okay, so that's all from me. Thank you.